Hello, so we're going to look at, hopefully you can see that front slide where it says different types of graphs. So we're going to be looking at different types of graphs today. So you looked at quadratics exclusively last lesson. We've looked at linear graphs before, they're straight lines. And we don't need to know too much about cubic and reciprocal graphs. I'll get into what they mean in a bit, but we need to know what they look like, and we need to be able to spot them from a diagram and to spot them from an equation, so some algebra written out, and we just need to say, yeah, that one's that and that one's that. There's not too much more we need to do with them at this stage. Quadratics is a different story, we've got to do a little bit more with that, but this is just a lesson where we touch on all four, and then we'll leave the others behind and we'll focus back onto quadratics. And by the end of this video, you will hopefully be able to answer these 5 questions I've put up here. So, what do these words mean? What do the graphs look like? How do I plot them? How can I recognise them from a graph? How can I recognise them from an equation? Hopefully we understand all 5 of them at the end. Very brief rundown of what I'm going to do in this video. I'm going to go on to Geogebra and we're going to have a look at some of the graphs. We're going to fill in a table here, which is kind of a coverall for how to kind of spot them. And then I'm going to do a very quick run through of what the worksheet attached to this will be, and just to give you a few little hints on that and explain the task a little bit better than I would do through typing. Okay, so I'm going to jump straight to Geogebra, and I use the downloaded version, but you can actually go onto Google if you want to do this yourself. It's a really great tool. Just type in Geogebra into Google, do this, click on it, and then you click Start Calculator, and you pretty much get the same thing. You can click off that if you want to, and you type into here, so y equals to x, very basic one, and you just type stuff in, press enter, and you can untick it and tick it and kind of show stuff up, and you can do some cool stuff with it. I can just do a few more advanced things on this, and I prefer it, but you don't need to download this at all. Using the browser one is completely fine if you just want to have a play around and if you want to check your graphs as well. So, first of all, we've got our linear graphs. So this is where we've got things where it's like y equals mx plus c. It's a straight line, basically. So no x squareds, no x cubed, no anything like that, nothing crazy. You can have y equals something x plus something. And if it's a positive, it looks like it looks on my screen. It goes kind of left to right up the stairs. And if it's a negative, so y equals minus 2x plus 3 this time, we can see that it goes down the stairs. And that minus 2 there is telling me the gradient. So every time I go 1 to the right, I'm going 2 down. And that plus 3 tells me where it crosses the y-intercept. And with my positive one, the 2x plus 2, every time I go 1 to the right, I'm going up 2. And I'm crossing the y-axis at 2. So that is what those mean, and we should be very familiar with that. They are linear graphs. Our quadratics, they're the ones that have x squared as the highest power of x. So this is your most basic one, y equals x squared. And we looked in the last time that if it was a positive x squared, it looks like a smiley face. And it can be shifted about a little bit, so we can have y equals to x squared plus 3, that's one you plotted. That just moves it up a little bit. That plus 3 again at the end is just saying where it crosses the y-axis, just like the linear. And we'll notice that with all of them, if it's just a number at the end, that's always where it's going to cross our y-axis. And then y equals to x squared plus 2x plus 3, let's say. I'll untick the rest. So again, that's a positive quadratic. It's got more x's in there, but the highest power is still a squared. So it is just going to be a positive smiley face looking quadratic. If you ever plot a quadratic and it does not look like a smiley face, you've done something wrong and you need to rethink it. And then if we have a negative one, hopefully we remember that that would be a frowny face one. So I've done y equals minus x squared plus 5. So that plus 5 is telling me it's going to cross the y-axis at 5, and it's going to be a frowny face type of graph. So if you ever see a minus x squared, we should be able to spot that it's something like this. Looking at our cubics, you might be able to take a guess that this is going to be ones where it's x cubed. So it kind of does a bit of a wibble wobble. So it goes up, flattens. Sometimes it goes up and down. I'll show you one that looks like that in a bit. But it goes up, it flattens, and then it goes back up again. And then if we look at one where it's going to do a bit more of a wibble wobble, plus 2x squared plus 3x plus 4. Actually, let's just leave it like that. So if you see on the right, I've got x cubed plus 2x squared plus 4. It's done a bit of a up, down, up, and they'll never do more ups and downs than that. They'll always just do kind of a 3-part, so up, down, up, when it's positive. And I've got an x squared in there, but it's still a cubic graph because the highest power is x cubed. So always focus on the highest power. And when we have a negative x cubed graph, it's going to kind of do the opposite. So my green one is the positive x cubed, and the blue one is my negative x cubed. And instead of going up, up straight, or up, down, up, it's going to go down, straight, down. So it kind of just does the exact opposite. And if I do one that's got a bit more of a wibble wobble in there, so minus x cubed plus 2x squared plus 2. I'll leave it like that. So this is a negative x cubed graph. So we've got a positive x squared in there, but because it's got the negative x cubed, which is the highest power, that kind of overrides everything else and makes it look like this. So it goes down, up, down. And really, that's as much as you need to know about cubics at this stage. Basically just what they look like when they're positive and negative. You need to be able to spot them from, like, they might give you like 9 graphs, and they say which one's a negative x cubed graph, and you've got to say that one. And you'll see that in the questions you do this lesson as well. And then our final one is going to be the reciprocal graph, and that's a bit of a weird one. It's where you do x is on the bottom of a fraction. So if you can see on the left here, it's done 1 over x. And it looks, if I zoom out, it looks kind of weird. It just kind of does one bit and then it disappears and pops back up over there. When you go ahead at plotting these, you'll see why. At this stage here where my mouse is, x is 0, isn't it? And if I tried to substitute x is 0 into this, 1 divided by 0, well, that would be infinity. So we can't actually plot that. So what we do is we can get really, really close to this line of x equals 0, but we can't actually ever plot a coordinate on here. And when we go ahead and plot it, you just kind of make sure your line is kind of arcing towards the axis but doesn't touch it. You don't need to go on forever. And just give 2 curves, and it is in 2 parts like this. When you plot some coordinates for it, this will become a lot more clear about how this happens and possibly why. We can also have things where it's like y equals to 2 over x, so it doesn't matter about the number on the top. It only changes it very slightly, as you can see. And we can also have y equals to 3 over x. Again, just changes it very slightly, moves it a little bit further away from the axis, but it'll just go close to the axis later on. And this is probably the one that's hardest to remember. If we have a negative reciprocal one, what it kind of does is it just goes into the other quadrant. So we've got 4 quadrants. We normally call this number 1, number 2, number 3, and number 4. A positive goes into 1 and 3, and a negative goes into 2 and 4. You can always just kind of convince yourself this by putting in a coordinate of a value of x. So if I do x equals to 1, you just see where the y value would pop out. So in this case, for my y equals 1 over x, if I put 1, I would do 1 divided by 1 is 1. So that's going to go 1, 1, which is a positive here. If I put it into the other one, minus 1 divided by 1 would be negative 1. So it would be 1, negative 1, and that would pop out somewhere down here. So we'd be able to see, okay, well, that one's going to be in these 2 quadrants, and that's going to be in these 2 quadrants. They're always diagonal to each other as well. That's all you need to know about reciprocals at this time. And what we call this line, where they get really close, what we call is they get infinitesimally close, which means very, very, very close. We'll call that an asymptote. You can look up a more exact definition of that, but it basically just means it gets really, really close to it, but it never touches it. If I go back to my PowerPoint, well, let's have a quick fill-in of this, and this will be some kind of the main notes we need in our book. So a linear equation, well, that's going to be in the form y equals to mx plus c. We can have stuff like y equals to 2x plus 3, y equals to 2x, y equals to x. You can have a negative in there, y equals minus x minus 3. Anything like that would be a linear equation. And when it's positive, it's going to go left to right up the stairs. And when it's negative, it's going to go left to right down the stairs. Obviously, these specific points I'm crossing, I don't really know. I'm just drawing the general shape of it. A quadratic is where the highest power of x is x squared. So we could have something like y equals x squared. We could have y equals to x squared plus x plus 3. We can also have negatives, y equals minus x squared plus 3x. Anything like that would be a quadratic. And when it's positive, it's going to look like a smile. And when it's negative, it's going to look like a frown. Again, these graphs don't link to anything specific, it's just the general look of them. And then a cubic, this is where the highest power of x is x cubed. So we could have something like y equals x cubed. We could have y equals to x cubed plus 2x squared plus x plus 3. The highest power is still x cubed. The stuff that comes after it doesn't change the general look of it. It changes the kind of the exact points and details of it. And we can also have something that's negative, so minus x cubed plus 3x squared plus 1. We don't need to have that x term in there. So when it's positive, it's going to look like this. So a bit of like an S on a side. It could also just flatten and go out, so it's one of them two. And then when it's negative, it just kind of does the opposite. So it comes down, flattens, and then comes down. Or it comes down, goes back up, and it goes back down again. And then a reciprocal, that's where we have something over x. So I don't really know how to write that in words, but it's something over x. So we could have 1 over x, 2 over x, 3 over x, minus 1 over x, minus 100 over x. I don't know. Do anything you want. And when it's positive, it goes into quadrants 1 and 2. You can see this is a good enough way to just to plot it. People understand what you mean when you do something like this. Make sure it doesn't touch the lines. And then when it's negative, it just goes in the other 2 quadrants. The way we're going to plot these, so pause it on that if you want to take them down as notes. And I'm just going to go to the Word document for us now. So I'll keep that. So this is what we're going to be looking at. I'm going to also attach some axes that will be specific to each question in case that helps you. If you want to print that off or work on a computer, if you've got a little drawing tablet like I do. And plot these graphs. So it looks like there's a lot of work, but once you get down to question 7, it's basically filling in blanks, and it's literally just like, okay, so is that a linear, a quadratic, a cubic, or a reciprocal? I'll look for what your highest power of x is, and so on and so on. Basically just filling in words. Here, you just need to write, well, is this a linear, quadratic, cubic, or reciprocal graph? What about this one? What about this one? So you just write in a word, basically. And then this one, again, same type of question. So once you get down to question 7, if you've kind of got that table in your notes and you've slightly understood it, you should probably be able to breeze through that in about 5 minutes. Might take a little bit more time plotting these graphs, but that's just because plotting graphs takes a bit of time, but it's really important practice. And you'll notice that there's the infinity there, and that is because when we do 2 divided by 0, well, that's not possible. No amount of zeros goes into 2, so it would be infinity. And plotting that like I plotted my reciprocals on the table in the PowerPoint. So hopefully that is okay for you, and thank you for listening.